it's Lee here. Before we start Mike's talk, I just wanted to add a note. On the night, Mike had just helped another speaker with their setup in a different room in a different floor of the building. So when he's got back and started his talk, he's slightly out of breath. Just wanted to say thanks to Mike for helping the other speaker out, and just to bear with him whilst he starts his talk. Enjoy the talk.
Okay, so this is supposed to be a 10-minute talk, so I'm going to try and do 10 tips for improving render performance in 10 minutes, so we'll see how that goes. Before we start, we should talk about what render performance means. This is literally the speed at which the browser can essentially parse and then display your HTML and your CSS. So it's not your entire application performance, it's literally just the speed at which it can render your HTML and CSS. Whew, still out of breath. Okay, let's go. So, tip number 1. Decide on mobile versus desktop first. So, your default CSS, that is the CSS that's not inside a media query, will always render faster than any CSS that is coming in a media query or that is overwriting other CSS. So despite the fact that kind of the industry standard at the moment is to build everything mobile first, actually you should think about your users and what devices they're likely to be using by default, and then build to those devices as your default, as that will result in a faster render. Essentially, the more breakpoints that you're using, the more levels of CSS cascading or overriding that you've got, the slower the browser will be to render it. Okay, point number 2, reducing repaints. So certain CSS properties force a repaint during the render process. A repaint essentially means where it has to recalculate where all of the elements are on the page. Certain CSS properties will affect large amounts of elements or potentially every element on the page and force the browser to recalculate where everything goes, which is what we call a repaint. The more of those that you've got, the slower the render process is. So we want to reduce the amount of repaints that the render has to do. A screen in general these days can only repaint once every 16 milliseconds. So every time that you use one of these properties, you're essentially delaying your render by at least 16 milliseconds because it has to wait for the next repaint. So the properties that can cause repaints are anything to do with CSS Grid, anything to do with Flexbox, width and height properties, transform, margin, and position. All of those can cause repaints. It does vary between different browsers and different versions of browsers, so it's not always the same, but generally those are the properties to watch out for. Okay, number 3, simplify your HTML structure. So this is kind of the one that people talk about the most, which is just avoid putting unnecessary HTML into your page builds. The more complex structures that you create, or the more nested HTML that you have, the longer your browser will take to parse that code, and then therefore obviously the longer it will take to render it. Particularly for this one, be mindful of libraries and frameworks. A lot of them require you to add additional HTML elements that you perhaps wouldn't if you weren't using that library or framework. Particularly some JavaScript libraries and frameworks actually will add additional HTML to your application for you, kind of without you realizing potentially. So be wary of that. CSS libraries are another one to pay attention to. So Bootstrap, the CSS framework, is particularly notorious for making you create these kind of elaborate HTML structures, which are probably more nested and more complex than actually you would necessarily need if you perhaps weren't using something like Bootstrap. So be aware of that and use the right tools for those jobs. Okay, number 4. Using modern layout techniques. So there's still a lot of applications, a lot of legacy code out there that uses float for layout. Obviously for a really long time, it was kind of the only way that we had to create effective layouts. So it's still very, very common, but actually float was never designed for layouts at all. It's actually a hack. Float was originally designed so that you could put images just next to text. That was the whole point of it. But we kind of turned it into this whole, no, we do all of our layouts on floats. But because it was never designed for that, the browser is actually not very fast at rendering layouts that are built with float. So instead, we should use the modern techniques like Flexbox and CSS Grid, which are specifically designed to do layouts with. More specifically, we should use Flexbox for individual components. So that's like the contents of each section. So that your header, your footer, the nav bar, calendar, sort of the things that go inside those bits of your page. Generally, we should use Flexbox for those. And then we should use CSS Grid to do sort of the overall page layout, so the entire page structure. That's what those two particular parts of the CSS language are designed for, and it's what they're best at, and it's what will ultimately result in the fastest rendering. Okay, number 5, improving your CSS selectors. So first tip is to reduce the length of your CSS selectors. The longer that your selectors are, the more complex they probably will be, and therefore one, the longer it's going to take for your browser to parse the selector, and 2, the harder it's going to be for your browser to kind of filter down the elements from the DOM, more processing required, and therefore slower rendering. IDs are always the quickest selectors. So in some scenarios, particularly if you've got a really complex HTML structure, using an ID rather than a really long selector can be a good solution. But be careful of using IDs because they have the precedence issue where IDs are much higher precedence over classes and tag selectors, so it can cause all sorts of bugs. Avoid using HTML structure dependent selectors. So that's selectors like the plus, the greater than, the tilde symbol that rely on a specific HTML structure to work. They're actually really slow and will slow down the rendering in general. Browsers just don't like having to calculate that kind of thing because they've got to look at several different elements at the same time. And yeah, finally, just avoid attribute selectors as much as possible, if not entirely. Use classes as much as possible. Attribute selectors are the slowest kind of selector that you can write in CSS, so we'll have an impact on your render performance. Okay, number 6. Google Fonts. This one's a little bit different from some of the others, but this one's mostly in here because there's something really interesting about Google Fonts that most people don't know, but let's talk about them in general. So obviously, for general performance, just limit or reduce the amount of non-standard operating system fonts you're using. So try and stick to the ones that are just built into the operating system in the browser as much as you can, because they're obviously the quickest and will always render the fastest. But if you are using external fonts like a Google font, then quite often, you'll actually know the letters that you need in advance. So it's quite common for people to use Google Fonts or external fonts for like headings or titles or company logos, that kind of thing. So if you know the text in advance, you can actually just tell Google which letters you need from the font file, and it will just download those letters rather than downloading the entire font file. So the example here that on this slide, on the end of your the URL that you provide to Google to get the font, you can add a query parameter of text equals, and then the value of the letters that you need, remembering to put in both the capital and lowercase of any version that you need. So if you need an uppercase and a lowercase e, you have to put both in there because they're different letters. And that will drastically reduce the amount of data that you're downloading from Google and therefore improve your render performance. Okay, number 7. Avoid or reduce slow CSS. This one should be fairly obvious, but some CSS properties are harder for the browser to render than others. So just being aware of what these properties are and trying to reduce their use as much as possible, or having a discussion around, do we really need to use this property in this scenario? How adamant is your designer going to be? Will benefit your render performance. So the particular culprits here are border radius, box shadow, opacity, filter, and transform. So things like box shadow, you can often get away with just not using them. How much are you really going to notice? Something like opacity, can you do it with an RGBA? It will be a little bit faster than actually using the opacity property, but ultimately will still affect the render performance. But if you've not got a layered effect and you're just after a particular shade, can you get the solid color rather than the opaque version of that color if you've not got a layered effect? So yeah, trying to avoid these as much as possible. And then the last one, not a property but a value, the calc value where you can use CSS to kind of compute things for you. Obviously, the more effort that you make CSS in the browser go to, the slower your rendering is going to be. So avoiding using calc as much as possible will speed up your rendering. So yeah, okay. So avoiding slow CSS. Number 8. Optimizing your animations. So animations is obviously one area where it can really affect rendering. So some properties are actually slower to animate than others. Generally, these are opacity, transform, again, from the previous slide, and any gradients as well. If you're trying to animate gradients, browsers really don't like that kind of thing because there's a lot of GPU and all sorts of things that are required to do that. So that will really have quite a big negative impact on your render performance and actually on the animations performance itself. So not just the initial paint, but then every subsequent paint whilst it's doing the animation. If you've got some animations that don't run on page load, so maybe have a delay or they run on a user interaction like a click or a hover or something like that, then you can actually tell the browser that you're going to animate a particular property. You can like prepare it and say, this element is going to animate, but it's not yet, and it will actually optimize that element for you. So you can do that with the will change property. So it's will-change as shown here. And then you can just comma separate, you provide a list of comma separated properties that you're going to animate of the current element. So if it's just static to start with, but when they hover over it, the opacity and the width are going to change, then we can provide this will change opacity width. And that will allow the browser to kind of prepare that element for animation and ultimately improve the animation that you get from it. However, be wary of this one because whilst it will improve the animation that you get, it will actually slow down the initial render of the page. So generally my advice for this one is don't pre-optimize, build your page, build your animations. If you're finding that when the animation starts, it's a little bit laggy to start with, then provide the will change property. If you just put it in at the beginning, what you're probably doing is just slowing down your initial render and actually not getting any benefit from it. So just be careful with that one. Okay, number 9, focus on the fold. So just so we're all on the same page, the fold is the part of your web page that your users see when they first open your site before they've scrolled. So it's essentially the viewport at the very top of your page. That's what we call the fold. So focusing on this will improve the perceived performance of your application, even if it won't actually improve the overall performance. So downloading and parsing CSS will block page rendering. So whilst when the browser is parsing your HTML and it gets to a CSS link tag, it will block any rendering until it's gone and got that CSS and downloaded it and passed it. So what we can do is we can load just the CSS and the HTML that applies to the application that's above the fold first. So that means putting just a trimmed down version of your CSS file in the head of your document, just enough CSS that applies essentially to all of the HTML that's above the fold, so that we're reducing the amount of CSS that we download initially, and so that it can render all of that HTML that's above the fold as fast as possible. And then we can put a link tag to a second CSS file further down actually in your HTML body, below where the fold will be, so that once the browser has rendered everything above the fold, it'll then go and get the CSS for the HTML that's below the fold, but the user won't see that. It'll happen before they start scrolling, hopefully, so it improves the perceived performance. There is actually a new property. This literally came out about 2 weeks ago, so this is brand new, called content visibility, which you can set to auto. At the moment, this is only available in Chrome, but it's coming to Firefox. What this will do is you can apply this to elements, pretty much every element, and then when the page renders it, it will check whether that element is going to be visible to the user or not. If it's not currently visible, so if it's scrolled off the screen, or if it's hidden for whatever reason, then it will just skip the rendering of that element. It will just say, no, we don't need to do that now because the user can't see it anyway. This dramatically increases the render performance by like 90% on average. So it is quite a big improvement, but it is, as I say, it's brand new. So But it's coming to Firefox. It's just been released in Chrome 85. It's coming to Firefox, but there are no negative impacts, so there's no reason you can't start using it now. If a browser doesn't know what it is, it will just ignore it. So just put it in everywhere. Yeah. Okay, so that's number 9. And number 10. Do everything else first. So my last tip is that all of these things have been kind of small render performance things, and they're all great tips and good things to know, but actually if what you're trying to do is improve your application's performance or the front end performance, there is so much more that you should do before you do any of this stuff. So optimizing your images is always the number one thing that you should do when you're talking about front end performance. There's a great app by Google called Squoosh.app, the link's there, which you can just put your images through and it will optimize them and make them download much, much faster, which will always improve your performance. Obviously, reducing HTTP requests in general on the front end will always improve performance. And caching, that's a whole other talk, but as, you know, caching generally improves performance. That's the whole point. If you want to find out more about sort of general front-end performance, I actually have a LinkedIn Learning course on improving front-end performance, which is coming out next month. So please go check that out. I'm quite happy to shamelessly plug that. Which is not just about render performance, but it's about overall performance of applications using caching and all sorts of things. But yeah, point number 10 is don't do any of the previous points. Do these things first. Then when you're trying to get to the minutia of improving your render, then you can do the other 9 points. Cool. Okay, so that's it. That's my 10 points for improving render performance. I hope you enjoyed it. Thank you very much. Please give me lots of feedback on joined in, and I will answer some questions. I can see some coming in the chat already.
Yeah, so thanks very much for that. First question, are there any tools for checking which elements are going to cause pages to be slow?
Yes. So both Chrome and Firefox have in their dev tools. You have to go and turn them on. It's in their settings of both. But there's a little tick box in both the settings of both dev tools called it's called something like display repaints. And essentially, when you tick that, what it will do is every time that the browser has to repaint a particular element, it will like put a box over the top of that element, like a semi-transparent box over that element to show you like this element has been repainted. And that box will then get gradually darker the more times it's repainted. So if you turn that on and then refresh the page, you can literally just watch which elements are your worst culprits and then work on those.
Brilliant, thank you very much. That's I've got a couple more questions. Would using a utility CSS framework like Tailwind CSS be better for performance? By using and reusing utility classes, your CSS would be much smaller and simpler as you're not writing complicated selectors. Also, aren't you overriding other CSS in your project because you're reusing, oh, sorry, also you aren't overriding other CSS in your project because you're reusing utilities?
So yes and no to that one. I have to hold my hands up first of all and say that I haven't used Tailwind a whole lot, but I am reasonably familiar with the idea of utility-based CSS. Generally, yes, the less complicated, I mean, as I talked about, the less complicated selectors you're writing and the less CSS cascading or property overwriting that you're doing is going to definitely benefit your performance. On the other side of that, with the utility-based CSS framework, you end up writing quite a few classes into your HTML. So it's got to apply more classes rather than one class with just a bunch of properties. It's then got to figure out, well, if I've got these 5 different classes, even though they don't have the same properties in them, it's kind of got to do some calculations there to make sure that there isn't anything overriding each other, and it can just do that. So, you know, pros and cons to this. Ultimately, will it be faster? It's going to be use case dependent, but it's probably faster than using something like the Bootstrap style framework.
Cool. One from Liam, content visibility : auto. It sounds nice. Is that a good reason why it isn't the default? Or is there any reason not to add it to every element?
Yeah, okay. So the reason it's not the default, well, one is it's really new. In order for it to work, is browsers have to do this thing called CSS container rendering, which is like more than an entire another talk's worth of stuff that I could talk about, but it's essentially completely changing the way in which a browser has to render. Chrome is the first one to do this. So they've just put it in, which is why they can now do this content visibility property. The other browsers don't render using this container-based rendering solution. So that's part of why the other browsers haven't got it yet. Could Chrome make this default on every element? Yes, probably. Would it cause any problems? Probably not. Only things I can think of, I guess, are if you've got things which initially render off the page but then animate onto the page, that there's various discussions around what's going to happen in that scenario. Is it going to sort of suddenly appear at the bottom of the screen halfway animated into the page if it hasn't figured out that it's visible quickly enough? So there's a few concerns with it. It is super new, so you know, apply it and see what happens and make sure that none of your animations and things break, particularly with things like modals, if you've got them popping up or moving around. But at the moment, the general advice from literally the Google Chrome blog itself is apply it everywhere, and as long as nothing breaks, then you're good.
Good. So the follow-up, is this going to be my CSS reset then? I don't know if that's so I don't know if that makes sense.
Yeah, so I guess if this becomes the norm, which you know, if it does work in the way that we all hope it's going to, then yes, I imagine this will probably be put into a CSS reset so that this is just done by default.
Cool. I have one question. When you were talking about above the fold, is there a tool that can just look at your web page, work out where the fold would be, and then just then the CSS you need to plug into your head?
Yeah, there is. It's called Critical CSS. It's a paid for tool, which is why I haven't put it in my talk, because I like open source stuff. But there is a tool called Critical CSS. It's not part of. It doesn't have like any kind of build process. It's just an online like web page based tool. You pay for it and then you point it at your URL, and it'll spit back a CSS file that applies only to what is above the fold. It's actually pretty good, but like I say, one, it's paid for, and two, you can't automate it, so it's a bit of a problem because you literally have to like go and manually run the tool every time you update your application. So you know, if you've got like a proper CI/CD pipeline, then that's going to be a real pain. But yes, in theory, you can use Critical CSS.
Cool. Has anyone else got any more questions?
I think we probably need to wrap it there.
Okay, brilliant. Break. Oh, well, thanks very much. Really, really interesting talk.